Hi guys, today we're going to talk about a new topic. This is going to be our fifth lesson in the unit, Pythagorean theorem. Pythagorean theorem is a formula that you use on right triangles, only on triangles that contain a right angle, like this one. And in order to apply the formula is a squared plus b squared equals c squared. You might have seen it or heard of it. You have to first know what the a and the b and the c represent. So a and b are used to represent what are called the legs of a right triangle. The legs are the two sides that create the right angle. Those are the legs. And the diagonal side, which I'll do in blue, the diagonal side, which is always located across from the right angle, that's why I'm drawing an arrow. On the opposite side of the right angle is the diagonal side, that's the C, that's called the hypotenuse. Hypotenuse. So the idea is that if a right angle is being created, then you'll always see a particular relationship between A, B, and C. Whatever the length of A is, if you square it and you add it with the square of the length of B, then that sum, what you get when you add those, will always be the C, the diagonal side, squared. That will only be true if a right angle is being created. Okay? So you have typical problems will ask you to find the missing side of a right triangle. So if you look at example 1, the directions say find each missing side length. So if you look at example 1, the missing side here, you have to first label A, B, and C. So the missing side length here, if you notice it's across from the right angle, that's your C. And these, A and B, it doesn't matter which is which. You could have called the 3B and the 7A. The legs A and B are interchangeable. And then you write the formula, a squared plus b squared equals c squared. And you're going to find the missing side length by plugging the numbers into the formula. So 3 squared plus 7 squared equals, and we're looking for c squared. You're going to square each number and put the answer underneath. So 9 plus 49 equals c squared. And you're going to add these and put the answer underneath. So it would be 58 equals c squared. Now to isolate c, if you think back earlier this year we did this, when it's being squared, the opposite of squaring is to take the square root. So you're going to take the square root on both sides, and what that does is, it's the opposite of squaring a number, is it gives you the c value by itself. So on your calculator, actually I should have written in our directions, round to the nearest, let's round to the nearest tenth for all problems. So on your calculator, you're going to plug in the square root of 58 and then round that to the nearest tenth. So when I round that to the nearest tenth, I end up with 7.6. That tells me that the missing side length over here was 7.6 because 3 squared plus 7 squared equals 7.6 squared. Okay? If you look at the next one, I'm going to first label A, B, and C. So I have across from the right angle is C. These are A and B. It doesn't matter which one you call A and B, but C must be the hypotenuse. It must be the one across from the right angle. And in this example, the triangle has been rotated a little bit. So you just go to the right angle and draw an arrow to the opposite side, and that's your hypotenuse C. So you write the formula, a squared plus b squared equals c squared. You plug the numbers in. 7 squared plus 10 squared equals c squared. Now you write the answers underneath. 7 squared is 49, plus 10 squared is 100, equals c squared. You write that sum underneath. 149 equals c squared. Then you take the square root on both sides to isolate c, and you end up with c equals, and you go to your calculator, square root of 149 is 12.2, if I round to the nearest tenth. So the missing side length is 12.2. Okay, now the next two examples are examples where when you start to label your A and your B and your C, you'll notice that this time C is given to you. And the A and the B, one of the legs is missing. So when I write the formula, a squared plus b squared equals c squared, I'm going to have 3.9 squared plus, and my B is, or it doesn't matter if you called it A or B, but one of the two legs is the unknown, and you're replacing C with a number. So that's what gives this one like a little extra step. Not that it's a big deal or anything, but 3.9 squared is going to give you 15.21. I just squared that on my calculator. Plus, I bring down the B squared equals, and then 11 squared is 121. So in here, the extra step is you have to subtract to isolate B. So you're going to subtract 15.21. So I am subtracting 15.21, and that's going to give me 105.79. So I have B squared equals 105.79. And now to isolate B, again, the opposite of squaring is taking the square root. So I'm going to take the square root on both sides and round to the nearest tenth. So I'm going to do square root of 105.79. And that gives me 10.3. I'm rounding 10.3 because the answer was 10.285. Okay? And then maybe you guys can pause me and try the next one. Example 4, I'm going to first label my A and my B and my C. So across from the right angle is the hypotenuse C, and then these are my A and B. It doesn't matter which one you call which. So I'm going to write A squared plus B squared equals C squared. I'm going to replace A, I don't know. I'm going to replace B with 2.7. Again, it could have been either way. It could have been replacing A with 2.7 and B could have been the unknown. But C, the hypotenuse, has to be 6.5 squared. So A squared plus 2.7 squared is 7.29 equals 6.5 squared is 42.25. And here I have to subtract to isolate A. So subtract 7.29 from both sides. I have A squared equals 34.96. And now I just need to take the square root on both sides to isolate that A. So now I have A equals, and I put in my calculator the square root of 34.96, and I get 5.91, so it's 5.9 to the nearest tenth. Okay, so you guys are going to do like 5 of these problems tonight for homework, and tomorrow we'll look at them. We'll look at some word problems related to this. All right, thanks.